What specific problem does the proposed method aim to solve regarding the interpretation of large language models, LLMs, on benchmark datasets?
The proposed method aims to solve the problem of misinterpreting the performance of large language models, LLMs, on benchmark datasets, specifically addressing the issue of Potemkins. Potemkins occur when LLMs can correctly answer benchmark questions, designed to test conceptual understanding, without actually possessing that understanding, leading to a false sense of competence. The method introduces a framework that clarifies the assumptions necessary for interpreting benchmark success as evidence of true understanding, highlighting that benchmarks designed for humans may not be valid for LLMs if their misunderstanding patterns differ. By developing procedures to measure the prevalence of these Potemkins, the method seeks to reveal the limitations of current benchmarks and ensure that they accurately reflect ILM's conceptual grasp, thereby improving the validity of evaluations. Ultimately, this addresses the broader concern of construct validity in assessing LLM capabilities through standardized tests.
How does the proposed method or algorithm work? Illustrate step by step the framework for defining and measuring Potemkins.
The proposed method for defining and measuring Potemkins involves a systematic framework that identifies discrepancies in conceptual understanding between large language models, LLMs, and humans. First, the framework establishes that a model has Potemkin understanding if it can correctly answer keystone questions, indicative of understanding, but fails to apply the concept correctly in practical tasks. The first step is to collect a benchmark dataset that includes keystone questions and tasks across various domains, such as literary techniques, game theory, and psychological biases. Next, the model is prompted to define concepts, and its performance is evaluated on 3 additional tasks: classification, generation, and editing. The prevalence of Potemkins is quantified by calculating the Potemkin rate, which is the proportion of tasks where the model answers keystone questions correctly but fails in application tasks, revealing a systemic issue in the model's understanding. Finally, an automated evaluation procedure is introduced, where the model grades its own responses to further questions, providing a lower bound on the rate of Potemkins based on discrepancies in its self-assessment.
Can you provide a simple yet illustrative example of a Potemkin and explain the reasoning behind its classification as such?
An illustrative example of a Potemkin is when a large language model, LLM, is asked to explain an above rhyming scheme and provides a clear and correct response, indicating it understands the concept. However, when tasked with generating text that adheres to this rhyming scheme, the LLM fails to produce rhyming words, demonstrating a lack of actual application of the concept. This situation is classified as a Potemkin because the LLM can correctly answer a keystone question, the explanation, but does not possess the correct interpretation of the concept, as evidenced by its inability to apply the knowledge in practice. The reasoning behind this classification lies in the misalignment between the LLM's performance on the benchmark, success in explanation, and its failure in practical application, which is inconsistent with how a human would demonstrate understanding. Thus, the LLM exhibits a superficial grasp of the concept without true comprehension, highlighting the potential pitfalls of relying on benchmarks designed for human understanding.
What advantages does the proposed method offer over traditional evaluation methods for LLMs in terms of assessing conceptual understanding?
The proposed method offers significant advantages over traditional evaluation methods for LLMs by explicitly identifying and measuring the prevalence of Potemkins, which are instances where LLMs can answer keystone questions correctly but fail to apply the concepts accurately. This approach highlights a critical misalignment between human and LLM understanding, revealing that traditional benchmarks, designed for human evaluation, may not effectively assess ILM's conceptual grasp. By utilizing a benchmark dataset that spans various domains and tasks, the method provides a structured way to evaluate both the explanation and application of concepts, thus offering a more nuanced understanding of LLM capabilities. Additionally, the automated evaluation procedure for measuring incoherence within LLMs allows for a lower bound estimate of conceptual misunderstanding, further enhancing the reliability of the assessment. Overall, this method transforms the evaluation of conceptual understanding from a superficial measure to a systematic approach that can uncover deeper inconsistencies in ILM's interpretations of concepts.
How was the method validated and tested against various LLMs? What datasets and criteria were used to measure the prevalence of Potemkins?
The method for validating and testing the prevalence of Potemkins in large language models, LLMs, involved two main procedures, using a benchmark dataset that spanned 32 concepts across 3 domains: literary techniques, game theory, and psychological biases, totaling 3,159 labeled data points. The first procedure specifically measured the divide between an LLM's ability to explain a concept and its ability to apply it, assessing tasks such as classification, generation, and editing. The second, more general procedure provided a lower bound on the prevalence of Potemkins by prompting LLMs to generate questions related to concepts they had previously answered correctly, and then grading those responses. The criteria for measuring the prevalence of Potemkins included the accuracy of definitions provided by the models, followed by their performance on the application tasks, revealing a high rate of discrepancies where models could define concepts correctly but failed to apply them accurately. The findings indicated that despite achieving a 94.2% accuracy in defining concepts, the models exhibited high Potemkin rates across all tasks, confirming the systemic nature of this issue in LLMs.
What limitations or drawbacks exist within the proposed framework for identifying Potemkins, and how might these impact the interpretation of the results?
The proposed framework for identifying Potemkins has several limitations that could impact the interpretation of results. Firstly, the framework relies on the assumption that the space of misunderstandings for LLMs mirrors that of humans. If this assumption is incorrect, the benchmarks may not validly measure understanding in LLMs, leading to misleading conclusions about their capabilities. Secondly, the framework's reliance on keystone questions, which are designed for human understanding, may not effectively capture the unique ways LLMs can misinterpret concepts, resulting in a potential underestimation of the prevalence of Potemkins. Additionally, the automated evaluation procedure provides only a lower bound on the prevalence of Potemkins, meaning that the actual rates could be higher than reported, further complicating the assessment of LLM understanding. Lastly, the framework does not account for the possibility that LLMs may exhibit coherent but misaligned interpretations of concepts, which could lead to an overemphasis on incoherence as a source of misunderstanding. These limitations suggest that while the framework is a step forward, it may not fully encapsulate the complexities of LLM conceptual understanding, potentially skewing the interpretation of the results.